Now, we can calculate colligative properties. To do that, we need to have a constant, okay, or some sort of multiplier. So to do that, F dot P stands for freezing point and boiling point. All we can calculate is the change in temperature. So what you do is you calculate the change in temperature and then add it to the original or subtract it from the original. So to find the change in temperature for freezing, we take the constant of freezing times the molality. Not molarity, molality. Because it has to be molality because we can't change temperature with molarity. So for example, if we look at water's Kf value, so it's constant for freezing, it's 1.86. So if you had a 2 mol solution and you had the Kf of 1.86, you take 2 times 1.86, and basically the result of that would tell you how much colder it would be to freeze. Okay. Now, there's one hiccup in this process. This is basically the effective molality. Now, effective, what we mean by that is number of particles. Okay. So if you have a mole's worth of sugar in solution, you get a mole's worth of solute. However, if you get a mole's worth of salt in solution, you get 2 moles worth of solute. So what happens is, because salt particles break apart into 2 separate ions, they get double the effect. Okay? So if you had a 1 mol solution of salt, what you really have is 2 mol instead of 1, because you have 1 Na, 1 Cl. Okay? If you had 1 mole of K3PO4, you end up getting 4 moles of solute. So you get a 5 or 4 times the effect with that ionic compound, because you get 3 K pluses and 1 PO4. Remember, PO4 stays together in the solution. All right. So if you take a look at it, if we're going to do a calculation here, let's just kind of do a practice problem together. Let's say I have a 2 mol solution of aluminum oxide in solution. Okay, so let's make it kind of a complex one. And I want to know what the freezing point is going to be for this solution, this 2 mol solution. Okay, so I know that my change in temperature of freezing is going to be my K freezing times my effective molality. Now my effective molality, though, is not 2, because I have 1, 2, 3, 4, 5 ions here. So I have 2 times 5. So I basically have the equivalent of a 10 molality solution. So that's the number that goes into our equation. Because we have, when this thing splits apart, you're going to get you're going to get 5 different ions. So if it's 2 mol, you actually have to double this. You end up with 10 ions in solution for that. Okay? So a 2 mol solution multiplied by the number of ions there gives us a 10 mol effective solution. Plug that into our equation, and now our change in temperature for freezing. We look up the Kf, which will be given to you, is 1.86. And that is going to be times our 10 mol. And the label for this is degrees Celsius per mol. So molality cancels, and we end up with degrees Celsius here. That doesn't look very good. Let's fix it. Degrees Celsius over molality. Molality cancels. So 10 times 1.86, well, that's 18.6 degrees Celsius. Okay, so my change in temperature is going to be 18.6 degrees Celsius, which means my original freezing point of water was 0 degrees C minus that 18.6. So my new freezing point would be a negative 18.6 degrees Celsius. Okay. Now, if you can tell, this is why we salt roads in the wintertime. Because we take a salt, we pour it onto the ice, that salt dissolves into the ice and makes a solution. That solution now has a much lower freezing point. So essentially what we're doing is we're taking the ice and we're generating a lower freezing point, so that now liquefies again, and we remove the ice from our roads. Okay. The exact same effect happens if you boil. When you boil, what happens though is the temperature raises. Okay. So same math, same process. You have a different value for Kb. So for water it's 0.512, but exact same math. But you gotta make sure that you don't subtract it. In that case, you add it to your boiling point for that. Okay. So here's 3 practice problems you can do. So please work through these 3 practice problems, and we will give you the answer key for these 3 in a minute. But work through these 3 practice problems and make sure that you can understand and do colligative property or boiling point elevation, freezing point, depression calculations. Okay, I'm going to give the answer key to all 3 of these now. If you would, please take the time to work them out before I give you these, because if I just give you the answer, it's not going to do you much good, and then we'll end the video. So I'm not going to give you the work, I'm just going to give you the numbers for these 3, and you can work it out and make sure they get you those answers for each one of these. Okay? If you're getting something that is half or a third of some of these values, keep in mind that you may not have factored in this effect up here of your different number of ions, okay, in terms of what goes on there. All right. If you have questions on this, please let me know. But that ends this video segment. Thank you.